All right, here's a video solution of problem 4.8. Okay, in this problem, we're given that we know that an aircraft will glide 2.0 times 10 to the first kilometers. Okay, so that's 20 kilometers from a height of 2 times 10 to the third meters. So we notice one is in kilometers, one is in meters. There's a TV tower located directly in line with the runway. If the pilot glides over the tower with 3 times 10 to the first meters to spare and touches down at the runway 6.5 kilometers from the base of the tower, the question is, how high is the tower? Okay, so let's draw a picture first, and then we can talk about the given and the find statements. Okay, so I think we can visualize the plane landing as forming a triangle. Okay, and we know that the tower, the transmitting tower, is somewhere in here. It was given that this height here was 3 times 10 to the first. Okay, so 30 meters to spare. Okay, and then we know that this will glide 2 kilometers, and we know that the original height was 2 times 10 to the third, or 2,000 meters. Okay. So we know all these things, and we need to know how high is the tower. Okay. So I think you can see we need to really know this length. Once we know this length, we can subtract off the 30 and get the height of the tower. Okay, so we're given several things. We're given that the aircraft will glide 2 kilometers from 2,000 meters in height. Okay, we're given that we clear the tower by 30 meters. Okay, and from there we can find the height of the tower. Okay. All right, so we know from trig that we can come up with the solution for the angle theta, all right, by the relationship that tangent theta is the opposite, so that would be 2,000. All right, remember this is in meters and this is in kilometers, so we need to convert kilometers to meters. Okay, and so I need to multiply that. Oh, I'm sorry, I didn't notice 10 to the first. This is 20 kilometers, not 2. Okay, so 20 kilometers. We need to multiply by 1,000, and we would get 20,000. Okay. All right. It's the same angle for the overall length L. And so we can write down tangent, let me erase that, tangent of theta is equal to the length L, okay. Oh, and we also know this length. That's part of our given. I forgot that one. We're given that we land 6.5 kilometers from the base. Okay, so we know that that's 6,500 meters is this length. Okay, so tan theta is L over 6,500. Okay, from there we can equate the two tangents. Okay, and from that we get that L over 6,500 is equal to 2,000 over 20,000. Okay, so from there we can get L. Okay, so that would be 2,000 over 20,000 times 6,500. And if we wanted the height of the tower, we solve for L and we subtract the original 30 meters. Okay. So when I go through those calculations, I get that the height of the tower is, well, let me plug it in. I get that to be 650 minus 30, so it would be 620 meters. Okay, now we check our significant digits. If we go back to the original problem statement, it looks like in some places there's 3 significant digits, but most places it's 2, so the least number of significant digits drives our final answer, and so we would report this as 620 meters. So there's a solution for 4.8.